Hello, welcome to another Great Cow BASIC demonstration. This one is going to focus on debugging using MPLAB X IDE. What have I got? I've got a board, and this board has a chip. It has an ADC that's connected to AN0, and we're going to read values as our debug. And we're going to warp the code in MPLAB X. So let's generate the code. So first thing we need to do is just determine the chip that's in here. Well, trust me, that's the chip. All right, so I can use PitKit Plus to tell me that. Let me just handcraft the code here. Explicit. I do that to ensure that I don't have any typos. All right, so I'm going to use create a value called debug value, and then I'm going to put a loop on it so it's just continuous. Okay, continually going to read the ADC. Shouldn't really have it do it all the time. And I'm going to read AN0, which I said before, and I'm going to put that value into the EEPROM. I'm only using this as a demonstration, right, to show you, yeah, that you can do this, okay? Now, let me just save that. Okay, so it's writing out the code to here, and then what we're going to do in a moment, using PitKit Plus, I can just read the EEPROM data value in here. It's currently 0 because I did this before, look. But we're going to look at different values, okay? All right. Great, that's just programmed it. All right, so let me just read the value. Oh, E9, good, because I'm just going to change that potluck to full on. I'm going to read that value, and it's F here. I'm going to tweak it back a bit, just so that we can see that different values, and we have some code that is operating. Okay, now this code is ADC, so let's just optimize the code before we go into that debug. We don't have to do this, but I'm going to do it anyway. All right, optimize the code, and it puts a load of constants in here. What I do, right, bit of a trick here, is I quickly replace all those trues with false, okay, and then the only one I want to use, set to true. When I generate the code, it will take it from 343 words. Let's have a look. 343 words down to 133 with 9 bytes of RAM. Okay, so it's just optimized it. And if we want to look at the ASM generated, we can press Shift F7 in here, or just to view the code, and we've now got our code. All right, so what we've got here is the meat of it, which is read the ADC, and then write it out and call two functions called readAD, or two methods called readAD and EEPROM write. So a little bit of code here on the left, but this is the assembler. Let's just create a project now in MPLAB. Okay. So MPLAB, I also want the chip name again. Create a project, new project. Select embedded standalone project. Insert the chip name. Select the chip. Select hardware tools, simulator. Select MPASM as your toolchain. Insert the file name as your project name. Great. We've now got a small MPLAB project, and I'm going to insert a source file. That source file is this ASM file. Take the full path name and insert that as an existing item. Insert it into the file name and select absolute. Nothing else is checked. Select. Now, as I recompile, those changes will be reflected in MPLAB ASM. So if I come into here and I want to change something, it will be immediately reflected in here. So what we'll do is we'll just change a config item just to prove to you it works. Okay, so I'm going to come up to the top, hash config lvp equals on. I'm going to regen the assembler. This is coming from the my IDE. And now if I go back into into here, we can see this is now being set to on. So we could do that live. I think there is a way I can do this live. We'll set that to off. And we'll see that change over here, off. There we go. Now, so we're using the as assembler from Great Cow Basic inside of MPLAB. So maximize that. 2 changes. Select the project, right-hand mouse button, properties. Select the global options of MPASM and build in absolute mode. You need that so we can track the variables, okay? In MPASM, uncheck enable case sensitivity, apply. We've now done the 2 changes. We can now start the project. So let's put a little break in here. Okay, so we can I'm going to set a breakpoint now, and then I'm going to debug the main program. I am now running. I'm in a program. So it's sitting here. It has a breakpoint. I can view memory by going into here, for instance. I can view the file registers, SFRs, config bits, etc., etc. EEPROM. This is where we want to see it. So if I come into the assembler down here, I'm going to put a little break there. Look, a new watch there. So sorry. I'm going to put toggle that, and I'm going to run through, and it's put a 0 in that EEPROM slot because the simulator doesn't have a value in terms of there is no pop. So let's attach a pop to it by giving it some stimulus in here. So stimulus. I'm going to take my AN0. Where is it? So to make this work, I select synchronous. I'm going to select ANA0, which is the pin, and I'm going to set it to a voltage. And why am I going to set it to a voltage? To simulate the ADC. I'm going to set that to maybe 4 volts, and I'm just going to run that and inject that into the code. I'm just going to run it up here, and it's run it once. Just trust me, it has. If I look at the EEPROM memory, it's now set to CC. Now, why is that? That's because if I set the voltage to 4 volts with a resolution of 255, I'd expect the value of CC. So what I'm getting is exactly the same as I get out on the real piece of kit. So 1, inject it, run it, look at the EEPROM memory. I get 33 in here. So if I set my little calculator here for you, I get the right values. So what's it doing? Let's walk the code. So this is clearing the value of the function that is going to return back. It's going to call a method called readADD2. It's then going to put the value of that method into the debug value variable. Oh, let's have a look at that. Add new watch. So that is in location 2, or already had it loaded, and you can see that I'm now seeing the value of debug value here. So I'm seeing the representative. So if I put a voltage of 2 in here, fire that, and I look at the variables, that hasn't changed yet because I haven't done a read. Let me just run it for you. And now I'm getting 66 because I've stopped it at this loop. It's now walking the code completely. So we can walk the code down to that method. It's setting up the left justify. It's setting up the port correctly for us. It's setting up the clock sources. And then it's doing it returns the value. And here is returning the value at this place here. Look, here we go. Look. So we can walk the code right the way through. We can do the same for other parts of the code as well. So if we want to put a little debug piece of, we want to put a debug in there, toggle that, run it. I'm now stopped here. Let's have a walk through and see how it writes the EEPROM. EEPROM write. It saves the state of the interrupt, sets up the addresses, puts the value writes the value of EE data, which is the set to 66, and puts it out into the correct register, and then sets up the rest of the operation and writes that out. So you can use MPLAB IDE to generate, simulate Great Cow BASIC code. Not one for the faint-hearted. As I said yesterday, it's not something I do very often. I don't need to. I would rather use other methods. But I wanted to do that piece of demonstration a bit more justice. And so we'll call that a wrap.